Good evening, students. Today we are going to discuss most important topic in graph theory, important problem as well as, right? So, what is the important problems? A simple graph with n vertices and k components have maximum number of edges is n minus k and n into n minus k plus 1 divided by 2 edges. Okay, so before go to the problem, we should know what is simple graph and what is components and what is maximum number of edges. So if you know all these three definitions, easily we can understand the concept of this theorem, right? So first of all, what mean by simple graph? So if I want to draw a graph, in that graph there is no parallel edges should not allowed, and also no loop should not be allowed. So it is called simple graph. So if I draw one graph, it is nothing but a simple graph. If I draw a dot, it is one of the simple graph. If I draw a line, it is the simple graph. So all the things are simple graph. So when we say it is not a simple graph, there is no loop and there is no parallel edges. So first definition is clear, what is simple graph. And the second definition, maximum number of edges. What is the formula? We already know. If a graph has n vertices, the maximum number of edges is n into n minus 1 by 2. It is the maximum number of edges for a graph. For example, if I take 4 vertices, right? 1, 2, 3, 4. How many edges we can draw? 1, 2, 3, 4 and of course 5 and 6. So it is the maximum number of edges. So substitute in this formula for this graph. How many vertices are there? 4 vertices. Substitute here n equal to 4. 4 into 4 minus 1, 3. 12. 12 by 2, 6 edges. So maximum we can draw 6 edges only. That is called maximum number of edges. So come to the next important topic, that is called component. What mean by component? So component is most important thing for understanding, for clear concept in this problem, right? What is components? So if I draw one graph, right, and I draw another graph line, and I draw another graph, so it consists, all the thing consists of a single graph G. So it is G is a graph. How many components in the graph? 1, 2, 3 components in the graph. That is called components. In a simple definition, maximal connected subgraph of a graph is called component of a graph. So if I take a subgraph, means it is one of the subgraph of this graph G. So don't consider that 3 graphs are inside of this graph. It is nothing but only one graph. This one graph contains 3 components. That is called components of a graph. So what is the concept here? If I take this example for this theorem, n is number of vertices. How many vertices are there in this graph? Not only 3, right? 1, 2, 3. Here only 4, 5 vertices, 6 vertices, 7 vertices, 8 and 9 vertices are there, right? How many components are there? 1 component, 2 component, 3 components are there. So it is nothing but n equal to 9, k equal to 3. So if I take 9 vertices and draw 3 components, maximum number of edges you can draw possibly is substitute in the formula, n equal to 9, k equal to 3. So 9 minus 3 is 6 into 7, 42 divided by 2. 21 edges we can draw. So how to draw the 21 edges, sir? So 9 vertices you can draw in a single graph. 7 vertices if I take this graph, 3, 6, 7 vertices. And 1 vertices, 8 vertices, 9 vertices. So we can't draw any edges for this graph, just leave it, these 2 edges. So remaining 7 edges. Draw the graph, draw the edges for this graph. How many edges you can draw? Just draw all the connection, all the adjacent vertices. Try to adjacent for each vertex is adjacent to all other vertices. Maximum number of possible graphs is 19, right? Because we can substitute, already we know that. What is the formula? N into n minus 1 by 2. For single graph we can draw, right? So 7 vertices are there. 7 into 6, 42, right? 42 by 2, 21 vertices, plus 1, 22. It is not edges, we don't have the edges. So only 21 edges we can draw when n equal to 9, k equal to 3. So it is the basic concept, right? Now, it is the basic concept. Now, I am going to prove the graph. I am going to prove the theorems. What is the theorem we are going to prove? The theorem is nothing but what? Once again recall the same theorem. A simple graph with n vertices and k components have maximum n minus k into n minus k plus 1 divided by 2 edges. Now only we are going to start the theorem. So before go to the theorem, each and everything is understood one. So first thing, how many component here we are going to take? K component. How many components here? Only k component. What are the name of the component? K, the component 1, component 2, component 3 and so on, component k. What is n1? Number of vertices in first component. n2, number of vertices in second component and so on, nk, number of vertices in k component. So totally k components in this graph. If we add all the vertices, right, k component, number of vertices in first component n1, n2 and so on, nk. If we add all the component, I get number of vertices in the graph G, that is called n. Is the first step. n1 plus n2 and so on, nk equal to n. So we can write a simple thing. All the steps are very simple. Summation I equal to 1 to k, ni, we can write the summation is equal to n. So first step is over, easily we can find it. So why we are going to proceed this step side? So I will continue the same. Before that I come here. What is this things? So number of component, I consider first component, second component and so on. If there is ith component, consider and so on. Totally k component, we know that. In first component, how many edges we can draw? We know that n into n minus 1 by 2. But vertices is n1. So n1 into n1 minus 1 by 2. In the second component, n2 into n2 minus 1 by 2. And so on. Ith component, ni into ni minus 1, ni into ni minus 1 by 2. Similarly, here n1 into n1 minus 1 by 2, n2 into n2 minus 1 by 2 and so on up to k. That's why simple concept, right? ni into ni minus 1 by 2. Because what is the value of I? 1 to k component. It is the actual formula we need. So in the next step we can consider ni into ni square, ni into minus 1 minus ni. So summation, look careful, I equal to 1 to k is already exist, right? Summation I equal to 1 to k, ni into minus 1 minus ni. What is the value of ni? Already we know that. What is the value of ni? K equal to, come here, k equal to, I equal to 1 to k, ni equal to what? N. So that's why here consider n. So now it is the fixed equation. It is the fixed equation. Now I am going to find the value of this main concept. Listen carefully. Ni square. Finally, I substitute the values in the equation, given equation, most important equation. Finally, I am going to substitute the values in this equation for the value of ni square. So now come to get how to get the value of ni square. So it is the trivial thing only, right? Summation I equal to 1 to k ni. What we can write? n1 plus n2 and so on, nk, right? In the next step, I want to eliminate one edge from each component. Be careful to understand. I want to eliminate one edge from each component. First component, remove one edge. Second component, remove one edge. Third component, remove one edge. And so on. Kth component, remove one edge. Then similarly, I want to remove one edge from left hand side also. So how to remove one edge from this component? Here there is k component, be careful, minus for first component remove 1, for second component another 1, third component another 1 and so on. Kth component another 1. So how many 1 is there? Minus 1, minus 1, minus 2 and so on. How many 1? K1. So value is minus K. What about the values? This value is Ni. So easily we can understand this step in the next slide. So what is the value of this slide? Be careful to once again. Ni, summation I equal to 1 to K, Ni equal to is nothing but N, right? Summation I equal to 1 to K minus 1. What we discussed in the previous slide, minus 1 plus and so on. How many minus 1? K minus 1. That's why minus K. That's why minus K. So what you get here? N minus K. What you get here? In the left hand side, what you get? Instead of this one, what about left hand side? N minus K. Left hand side is what? N minus K. So now come to the equations. I want to remove all those things. It may be confused for you. Yes. Now come to the definition. This term is nothing but N minus K. Right hand side nothing, the same equation. N1 minus 1 and so on. Nk minus 1. So it is the major step for make you confused, but clear definition I will give. So be understand. So now I am going to square on both sides. N minus K whole square. Right hand side N1 minus 1 plus N2 minus 1 and so on. Nk minus 1 whole square. This step only. Right? So what I am going to write? This step, whole step is nothing but what? I am writing here. Please careful what I am writing here. Equal to N minus K whole square. Equal to N minus K whole square. Actually, we know the formula for this N minus K whole square. N square plus K square minus 2Nk. Then how to get this step? It is the confusion step. So be clear how to write clearly this step. So what is the formula we denoted here? A plus B plus and so on goes to up to whole square. So easily we know the formula for A plus B whole square. A square plus B square plus 2AB. But here A plus B plus C plus and so on continue up to K. That's why I am writing A square, right, plus B square plus and so on Nk minus 1 whole square, and some of the term may be omitted. What are the term? 2AB plus 2BC. Well, just like that. Okay, I want to omit that term. That's why so here lot of terms is there. A square plus B square plus C square and so on Nk minus 1 whole square, and of course 2AB plus 2BC and so on. I want to remove that kind of term. 2AB, 2BC and so on means what happened? This value may less of this value because it is the fixed value. N minus K whole square is the fixed value. Am I right? N minus K whole square is the fixed value. But I want to eliminate those value. That's why I put less than or equal to, because I remove some of the values from left hand side. It may be confused and extend to infinity. That's why I remove some value. That's why this value less than or equal to N square plus K square minus 2Nk. After that easily we can write. It is the simple formula A minus B whole square. A square plus B square minus 2AB. And A minus B whole square. A square plus 2B square minus 2AB. And so on. Nk minus 1 whole square. Nk square plus 1 minus 2Nk. That's all. Then listen the next step. It is as usual. N square plus K square minus 2Nk. Come to the next step. N1 square plus N2 square and so on Nk square is nothing but Ni square I equal to 1 to K. First term is okay. Next term, look careful. Minus 2 N1 minus 2 N2 minus 2 Nk. If I take minus 2 N1 plus N2 plus Nk, right? N1 plus N2 plus Nk. And the next step, 1 plus 1 plus 1 and so on plus 1. How many 1 is there? Already the same thing we discussed. K1 is there. First term for 1, second one, third one, and so on. K component 1. So K1 is there. That's why this K. Right? In the next step, Ni square, we know that, right? You may consider the same thing. N1 plus N2 and so on, Nk is equal to N, right? Plus K. Now in the next slide, we take these two terms into right hand side. What about the term in right hand side? N square plus K square minus 2Nk minus 2N comes to right hand side plus 2N, right? Plus K comes to right hand side minus K. What happened here? Let me check the second one. Plus 2N minus K comes to right hand side. Am I right? Plus 2N minus K comes to right hand side. So what the formula? Known very well formula. A minus B whole square. Right? So what the value we obtained? Value of summation I equal to 1 to N 1 to K Ni square. Already discussed in the first slide. It is the answer already, right? Summation I equal to 1 to K Ni square. I got this value. What is the value of this one? Summation I equal to 1 to K Ni square. Once again, this is the final answer. We got this value, right? Simply I substitute the values here. Ni square is equal to what? Less than or equal to Ni square. I am having the same thing here, right? Ni square. What is the value of Ni square? Check here. I substitute here. Instead of Ni square, what I am going to write? I substitute this value. I substitute the value. Instead of Ni square. N square minus 2Nik plus K square. That is equation 3. Consider the equation 3 minus K. Minus 1 by 2N. That's all. The same term writing here. Because it is the maximum number of edges we are going to find out. Right? Maximum number of edges we are going to find out. So in the next step, simply it is nothing but the formula, the same formula, A minus B whole square. Right? A square minus 2AB plus B square. A minus B whole square. Here 1 minus N minus K. If we take N minus K, what the term we are getting here? Here only 1. Here another N minus K. Because N minus K whole square. So what we get? N minus K into N minus K whole square plus 1. So to say N minus K into N minus K plus 1 whole divided by 2. What mean by this less than or equal term? That is maximum we can draw this right hand side only. Right? After that we can't draw the edges more than this one. So maximum number of edges is nothing but what? N minus K into N minus K plus 1 divided by 2. It is the most important theorem. I hope everyone will be study well regarding this theorem. Okay, thank you. We will meet again in the next theorem. By using the next theorem in graph theory, we will discuss in the next class. Thank you all.